හරි අපිට අද හතරවෙනි paper question number 4 paper number 4 discussion එක තියෙනවා. බලන්න මාත් එක්කම ඒකේ discussions ටික කරද්දී ඔයාලා corrections ටික කරගන්න. Okay, let's start. Part A. First I move to question number 2. Question number 2. Okay, do with me. Here particle is projected from a point 2 meters above the ground. 2 meters above the ground with initial velocity 40 meters per second. Now it is a projectile motion. Inclination 45 degrees to the horizontal. Find horizontal distance from the point projection when hit the ground. We need to find this R. Here 2 meters height. AB, for projectile motion, AB motion, consider S equal ut plus half a t square. Ut plus half a t square first vertically, then vertically upward, displacement minus 2, 40 sine 45, 40 sine 45 t minus 10 over 2 t squared. Do with me. Then simplify this. Here 5 minus 2, 40 sine 45, 1 over root 2 t minus 5 t squared. Then here 20 root 2. Then 5 t square minus 20 root 2 minus 2. Minus 2 equals 0. Here quadratic equation, find t. T equal minus b plus or minus b square minus 4ac. Root divide by 2a. 2a. Then simplify 4, here 10 to 10. Then 10 root 2 plus or minus 100, 200. 200 plus 10, 210. Root divide by 5. Then since t greater than 0, then t value take 10 root 2 plus 210 root divide by 5. Okay. Here we have irrational values, but don't worry about that. Just continue the procedure. Here the time in seconds. Check simplifications. Huh? Here 10 root 2. Here 10, 100, 200. Here 4, 5 to 10 to 10. Okay. Then horizontal displacement, use horizontally same equation. Then R equal u cos 45, 40 cos 45 times t. Then 40 cos 45, 10 root 2, 210 square root divide by 5. Now it is in meters. Then 8, 10 root 2, 210 meters. Here horizontal displacement. Simple question, but the value somewhat hard. Irrational simplification. Then question number 3. So here take this diagram. Here 60 degree inclination, 30 degree inclination. Here two objects. Here mass km, then weight kmg. Here mg, reaction R, reaction R2, R1, tension T, T. Here fixed, na? Fixed. Fixed horizontal, wedge is fixed. Then you take acceleration F, then F equals ma, simple m particle upward, then T minus mg sine 60 equal mf, then km downward, kmg sine 30 minus T equal kmf, then 1, 2, then add them, 1 plus 2, kmg sine 30 half, mg sine 60 root 3 over 2, mf, kmf. Now simplify subject f. Then here g over 2 common, take it outside, k minus root 3 over k plus 1. Here f value. Then it provides that k greater than root 3. Therefore, f greater than 0. Therefore, mass m moves towards p. Moves towards p. Simple fraction. Here just pulley system. Just pulley system. Okay. Okay. Here u cos 45 1 over root 2 එකක් එනවා. and 4 root 2 නේ. 8 4 root 2. Okay. Then question number 4. Question number 4, work power energy question. So you can do this one using just physics. Then question number 4, mass of the train 20 metric tons, 200 metric tons into 1000 kilogram mass. Maximum speed 20 meters per second. Because of this maximum speed, say acceleration 0. Acceleration 0. It moves up a hill. Alpha inclination, take this train with inclination sine inverse 1 over 50. Then here 200 into 10 to the power 3 into 10 Newton weight. Reaction R. Then here resistance say R, here R1. Then tractive force say P. Then here power given 800 kilowatts. Then H equal PV equation. We have only one equation, H equal PV. Then H equal 800 10 to the power 3 P, that time velocity 20. Then simplify. Then P value equal 40,000 newtons. Then use upward F equals MA. Then P minus R minus 200 10 to the power 3 into 10 sine alpha equal 200 10 to the power 3, acceleration 0. Acceleration 0. Then P equal 40,000. Then 200 times 10 to the power 3 times 10 times sine alpha 1 over 50 equal R. Then here 40,000 R value 0. Then no resistance against the motion. No resistance against the motion. Then here work power energy question. Okay, work power energy question you do using physics. We haven't done it still. We haven't done that question still. Okay, then let's move to question number 5. Question number 5. Do with me. A car of mass M turning corner of radius R. Here it is. Here the car. So here mg reaction R, frictional force towards center. Here center. Here center. Its radius simple R given. Coefficient of friction F. Now at the maximum speed, F equals to mu R. F equals to mu R. Then consider vertical forces R equal to mg. Then mu mg. Then here circular motion. We need to find the maximum speed. Vmax. Then use towards center F equals ma, then F equal m radial acceleration v square divided by r. Okay. So horizontal circular motion. Horizontal circular motion we use towards center F equals ma and vertical equilibrium. Here vertical equilibrium and F equals mu r, that is for maximum, the maximum case. Then simplify. F mean mu mg mvm square divided by r. Simplify. Then vm equal mu gr root. Mu gr root. Here maximum speed of the car. That is question number 5. Then question number 6. Question number 6. Here need to prove cosine rule using vectors. Take here A, B, C. Here vector A, vector B, say here vector C. Then vector C equal vector A plus vector B, no? Vector A plus vector B. Then C dot C equal vector A plus vector B dot vector C. Then C dot C modulus C squared. Then here A plus B dot A plus B. Then expand A dot A to A dot B, B dot B. Simplify modulus A square, modulus A square, A dot B, modulus A, here, modulus B, cos theta. Here you have to put angle, here this one. Here angle A, pi minus A. Angle between the vectors here, vector B, no, then pi minus A. Cos pi minus A plus modulus B square. Then modulus A, say A, modulus B, say B, modulus C, you say C. Then finally C square equal here A square plus 2AB cos pi minus A minus cos A plus B square. Then subject cos A equal A here cos AB, A square plus B square minus C squared over 2AB cos A අපිට මේක vectors ටික පොඩ්ඩක් මාරලානේ. Vector A, here vector A, here vector B, here vector C, yeah, vector C. Then vector A equal B plus C, B plus C. Then here put A dot A, B plus C, B plus C, vector A here, then B plus C, B plus C, B plus C, B plus C. Then here modulus A square, modulus B square, modulus BC, cos pi minus A, here modulus CC, 2BC, here B dot B, then C square, then A square, B square, BC, C square. Now it is okay. Then cos A equal B square plus C square minus A square divided by 2BC. BC. Do that correction. That is question number 6. Question number 6. So using dot product, we can derive cosine rule. That is very rare case. Complete. Okay, now let's move to question number 7. Question number 7. Here, hemisphere of radius r, weight w in equilibrium on smooth horizontal plane in contact with curved surface. Base incline. Now here, symmetrical axis. Here touch. Then reaction vertically upward. Then center of gravity 3r of weight vertically downward. Then these two forces are parallel. Therefore, there's a string. Therefore, that also must be vertical. Put T. Take angle theta here. Take angle theta. L value less than r. Here radius r. Here L. Here L. Here radius r. Therefore, when you consider this triangle, here radius r, here r, here this part L, r minus L, find this side, r square minus r minus L square root. Then you simplify. Then here L square plus 2RL root. RL root. Okay. Then take moment about this point O, about O moment, T times, here perpendicular distance r cos theta, W times, here theta 90 minus theta theta, then 3r over 8 sin theta, 3r over 8 sin theta. Then you find T value, tension in the string, 3W divided by r tan theta. Then 3W over 8 tan theta value, right, r minus L divided by L squared plus 2RL root. Okay. Here r, L, r minus L, L, r square minus r minus L squared. Here on simplification, 2RL minus L squared. 2RL minus L squared. And here 2RL minus L squared. Find reaction of the body, then vertical forces R equal W plus T. W plus T. Then W plus 3W over 8 R minus L 2RL minus L square root. Here reaction. That is question number 8. Okay, complete up that question number 8, 9, 10 and 1 I'll do later. Question number 1, 8, 9 and 10 I'll do later. Okay, then let's move to question number 11. Let's move to question number 11. Okay, now see. Question number 11 part A. 11 part A. Vehicle X start from a point A with 0 velocity at t equals 0. Here t equals 0, initial velocity 0 with uniform acceleration f. Here x. At time simple t, here t equals t case. Same point, here t equals t. Here y train with initial velocity u start and retardation kf. kf. Here time velocity, here train at 0 velocity, here it is train x. Then at t equals t, the second start with velocity u and retardation. Here this is y. y. Okay, take this angle alpha, take this angle beta. Then say tan alpha equal f, tan beta retardation say kf. kf. Okay. Then further it says that they just meet, both vehicles just meet condition, that meet in position will be velocity same position, just meet. Then here the position just meet position. Take this time simple t, take this velocity v. So anyway, both of them start at same point, then their displacement must be same. Therefore, you consider O, A, B, here C and here D. OAB area equals CDAB area. CDAB area. Because they move same displacement but different times. Then OAB area half into here t plus t times V. Half into here trapezium area simple t times U plus C. Here you can simplify a little. TV, TV, TU, TV. Cancel TV. Then TV equal TU. Here we don't know simple V, we don't know simple T. Say this equation 1. Okay. Then further acceleration tan alpha equal F V divided by simple T plus capital T. Then V equal F T plus T. Second equation. Then tan beta retardation, that is kf here u minus v divided by simple t time. Okay. Then here third equation. Now we have three different equations. Then you can solve them. Okay. Then thereafter you get k value equal u square minus 2 fut f square t square. Okay, start doing and let's simplify. Here v equal kft u minus kft. Then here these two same, no? ft plus t u kft. Then F given, capital T given, U given, simple T, you can find, no? Then FT, F capital T, U, KFT. Then subject T, FT, KFT, U minus F capital T. Then take T outside, TF 1 minus K. Here 1 plus K, no? Here FT, KFT, U minus FT. Okay. Then U minus FT. U minus F capital T. Then T equal U minus F capital T divided by F 1 plus K. 1 plus K. Here it is. Then you can find V value. By this you substitute here or here, whatever it is, okay. I'll substitute here. Here fourth equation V value U minus KFT. Then U minus KF simple T value U minus F capital T over F 1 plus K. Now just simplify, cancel F, U, K, U minus F capital T, 1 plus K, then get denominator 1 plus K, then U plus KU minus KU plus KFT. KU cancel, U plus KFT divide by 1 plus K. Here V value. Okay. Then here take first relation, still we haven't used that. Then take that relation. Then take first relation, TV equal TU. TV value, put this on U plus KFT or 1 plus K. Simple T value, here it is, U minus FT. U minus F capital T, F 1 plus K times U. Now simplify this. Cancel 1 plus K. Here we have F, then TF, U plus KFT. Here U square minus UF capital T. Then we need to subject K, no? Then TFU, UFT plus KF square T square equal U square minus UFT, UF capital T. Then K equal U square minus 2UFT divided by F square T square. U square minus 2FTU divided by F square T square. Here it is. That's how you do the simplification. Here, special point, just meet special. Just meet mean velocity same position. Velocity same position, they meet. So initially they start same position. When they meet, their displacement must be same. Their displacement must be same. At displacement same, at velocity same position. That's the specialty. Okay. That just meet, underline that word. Complete that. Do soon. take further little time and complete. Okay. Then question number 11 part B. 11 part B. Relative velocity question. The plane travels from A to B and come back to A. B is situated north of A. B is situated north of A. D kilometers. The velocity of wind W in the direction of southeast, towards southeast. Here southeast. The velocity of the plane V and W, velocity of the wind W in the direction towards southeast. Here southeast, W. Then velocity of plane with respect to Earth, here 45 degree, W. Velocity of plane with respect to wind in still air, it is given V. Then it moves A to B and come back. Therefore, velocity of plane with respect to Earth, here we have two cases, upward and downward, A to B, B to A. We have two cases. Then consider that data set. Consider that data set. Here, this one contain only magnitude, this contain both magnitude direction, this contain only magnitude. Then subject this and write relative velocity theorem. Then VPE equal VPW plus VWE. Here PW, V, WE, WE, here W, no? Velocity of wind. Then 45 W. Now put PQR notation. Here say PQ, here QR, resultant PR. Here R1, here PR2. Here put X, RX vector. Then sketch PR. Here PQ vector. Here PQ, W, inclination 45. QR magnitude B, surely that must be greater than W, okay? Then center Q radius V circle, sketch center Q radius V circle. Here the circle. Then here P. Then here PR1, PR2. Now here the velocity diagram. Here V, here V. Here two cases. Now find this one. Here W, no? Then here this length W sine alpha, that means W over root 2. Here V. Then you find this length, say that one C. Let's say B. Then here V, W over root 2, apply Pythagorean. Then B equal V square minus W over root 2 square root. Then 2V square minus W square root divided by root 2. That is B value. Then PR1, B minus W sine 45. Then 2V square minus W square root W over root 2. Then PR2, here B plus W sine 45. B plus W sine 45. Then simplify. Then 2V square minus W square root plus W over root 2. PR1 and PR2. Those are the relations. Now, the total time taken. Then total time taken, say, T equal displacement D over PR1, D over PR2. Then D, PR1 plus PR2 over, get common denominator, PR1 times PR2. Then PR1 plus PR2 addition, here we can cancel negative terms, then twice of 2V square minus W square. Twice of 2V square minus W square over root 2. PR1, PR2, here product of these two, conjugate pair, no? Conjugate pair. Then simplify, difference of 2 square term. Then 2V square minus WV square minus W square divide by 2. Now simplify. Here root 2, 2V square minus W square root divide by, here 2V square, 2W square cancel, V square minus W square. That is the relation. Complete. Complete. Okay. Now, then let's move to question number 12. Question number 12, relative acceleration and circular motion part. So 12 part A. Here there's a wedge given, inclinations alpha and alpha, two particles. Here M1G, M2G, and here M3G, R1, R2, R3. Here tension T1, T1, T2, T2. So here we need to write only equations to determine accelerations. Okay. Then you take here mass capital M is given. All forces are there now. Now take acceleration simple F. Alone is means same acceleration A. This acceleration. Always alone string accelerations are same. Then simplify this now. Acceleration of capital M with respect to Earth, F. Then acceleration of M1 with respect to Earth, addition of these two. Here F, here A, alpha. Acceleration of M2 with respect to Earth, addition of these two, A plus F. Acceleration of M3 with respect to Earth, addition of these two. Here alpha, AF. Then use F equals MA. Consider full system horizontally, no resultant forces horizontally, 0. Then M times is acceleration F, M1 times here acceleration F plus A cos alpha, plus M2 times here A plus F plus M3 times F plus A cos alpha, first one. Here simple M1 upward, T1 minus M1G sin alpha, M1 A plus F cos alpha, Here second one. Here M2 horizontally, T2 minus T1 equal M2 A plus F. Here third equation, then M3 downward, M3G sin alpha, minus T2 equal M2, take acceleration from here, A plus F cos alpha. Now here fourth equation. Now here we have four different unknowns, two accelerations, two tensions, and we have four different equations. Then definitely you can find at least one. Then here are the equation required. Okay, complete it. Okay, now let's move to question number 12, part B. 12, part B. Here, particle moves in a vertical circle on a smooth inner surface of fixed hollow sphere of radius say center O. Here it is now. Here, lowest point velocity u. So it leaves the surface OP making angle upward to O. Here it leaves at this point. Here mark forces mg r, say velocity v. Here r0, r equals 0. Consider E0 level here. Here we have vertical circular motion, no? Vertical circular motion. For vertical circular motion, we usually use F equals ma towards times conservation of energy. First use conservation of energy. Then conservation of energy. Initially half mu square equal half m v square here energy plus mg a plus here a cos theta, a plus a cos theta. Here kinetic energy only, here kinetic energy plus potential energy. Simplify now. Then v square equal u square minus 2ag 1 plus cos theta. Here first relation. Then use towards center F equals ma r plus mg cos theta equal m radial acceleration v square divided by a. Towards center F equals ma. Here r plus mg cos theta m radial acceleration v square divided by a. V square divided by a. Then you simplify this. R value 0. Here 0. Mg cos theta m over a v square. Now simplify. Then ag cos theta v square you put this one. U square minus 2ag 1 plus cos theta. 1 plus cos theta. Okay. Then you subject cos theta. Subject cos theta. Then 2ag cos theta with this one 3ag cos theta. Then cos theta equal u square minus 2ag divided by 3ag. 3ag. And further given, if cos theta equal 4/5, cos theta 4/5, 4 divided by 5, then get right angle triangle, then theta 4, 5, 3. 4, 5, 3. Then thereafter it motion, projectile motion, it goes like this, goes like this. Then we need to find this height. Let's sketch this say. Here initially simple a distance, here O, then here a cos theta, here a no, then here a cos theta, then projectile motion, velocity v, it goes like this. Take this point, height simple h. Then here angle theta, 90 minus theta to the horizontal angle theta. To the horizontal angle theta. Then at that point you find v. Here cos theta, find v. Then v equal when cos theta equal 4/5. Then substitute here v square equal u square minus 2ag 1 plus 4/5. Here 5, 9, 18. U square minus 18 ag divided by 5. First do up that. Do up that. Okay. Now let's move a little further. Now here cos theta u square minus 2he divided by 3he. Cos theta given 405. 405. Simplify. Here 5u square 10he 12he. Then u square equal 22he divided by 5. U square value 22he divided by 5. Then take that one, put it here. Then 22he 18he divided by 5. Then v equal v square 4he divided by 5 roots. Here the projectile motion initial velocity. So when it leaves the surface, thereafter it moves under projectile motion. Then its initial velocity 4he divided by 5. Okay. Then for the projectile motion, horizontally use s equal ut plus half a t square first. Then here displacement a sin theta. We need this height now. Then here a sin theta, horizontal displacement a sin theta, v cos theta, t. Then t value equal a divided by v tan theta. Now simplify. A divided by v mean 4ag root divided by 5. Tan theta mean here tan theta 3/4. Now simplify here. 3 root 5 over 8. A divided by G root. Here it's time. Okay. So it moves like this. Projectile motion. For this displacement, you find time. Then vertical height we can find. Then upward use v, v equal s equal ut plus half at square. Half at squared. Then initial velocity v sine theta. Here height h t minus g over 2 t square. Now v mean 4h root divided by 5 root. Sine theta 3 over 5. T value 3 root 5 over 8. A divided by G root G over 2 T square 3 root 5 8 A divided by G root square. Now that is H value. Now just simplify. Okay, let's do that. Now here cancel root 5 and here root G, then here 4, square root mean 2, no? Then here 4, then 3, 3, 9, 4, 5, 20, root A, minus, here cancel G, here 9 into 5, 45, 64 times 2, 128, A. Here it is. Now from height O, height from O, from here, A cos theta plus H, no? A cos theta plus H. Then A cos theta plus H. Cos theta, that is given 4 divided by 5, no? Here H 9A over 20, 45. H divided by 128. Now get common denominator 20. Then here 16, 9, 25A, 45 over 128. Here A value, A. Now 5, 4. Then 5A divided by 4, 45A over 128. Get common denominator 128. 5 into 32, 32A minus 45. 45A 128. 115A divided by 128. Here height from O. So you need to simplify clearly. Yeah? So here from here it moves away from the circular motion. Thereafter it motion projectile. So theta given in terms, then you find u value, then you find v value. Thereafter projectile motion height, take this height. Complete. Complete. හරිද ඔයාලගේ එක්සෑම් පේපර් හරියටම මේ ස්ටයිල් එකටම තමයි තියෙන්නේ. මේ ස්ටයිල් එකටම තමයි තියෙන්නේ. මේ විදිහට යන එක්ස්ප්‍රෙෂන්ස් එන්න පුළුවන්. හැබැයි සාමාන්‍ය පාර්ට් A B කොටස් දෙකක් තියෙනවා නම් ඒකේ එක්ස්ප්‍රෙෂන් එකේ weights අඩු වෙනවා. ඒ කියන්නේ A කොටස B කොටස ගත්තොත් A පාර්ට් එකටයි B පාර්ට් එකටයි ලොකු weight එකක් එන්නේ. ඒතර ඒ තියරි කන්සෙප්ට් එක අහනවා නම් ඉක්වේෂන්ස් ලියන්න කියලා විතරක් කියලා නතර කරනවා. සිම්ප්ලිෆයි කරන්න දෙනවා හරි අඩුයි. ඉතින් කන්සෙප්ට් එක හරියට ඔළුවේ තියෙන්න ඕනේ. දැන් question number 12 එකේ එහෙම තැනක තියෙනවා. question number 12. Okay, then let's move to question number 14. Question number 13, simple harmonic fraction. I'll discuss that one later. Then question number 14. Okay. Then question number 14, part A. Here vector A, vector B, non-zero, non-parallel vectors. Now alpha A plus beta B equal null vector. So we need to show that happen if and only if alpha equals 0, beta equals 0. If and only if alpha equals 0, beta equals 0. That theorem proof. Here we have 4 different sections to prove this theorem. Now let alpha equals 0 and beta equals 0. Here case 1. Then left hand side 0 alpha A plus beta B. Here 0 A, 0 B. Then null vector, null vector, null vector equal right hand side. Therefore it is true. True. Let alpha equal 0. Then alpha A plus beta B equal null. Here 0 A, beta B 0. Then here null vector, null vector. Then here beta B vector null. Therefore B non-zero. Therefore beta equals 0. Therefore when alpha equals 0, then beta equals 0. When alpha beta equals 0, here true. True relation. Okay. Then similarly, third one. Similarly, when beta equals 0, alpha equals 0. Yeah, alpha equals 0, then beta we get 0. Similarly, you say when beta is 0, alpha will be 0. Then fourth case, when alpha not equals 0, beta not equals 0, then alpha A plus beta B null, then alpha A equal minus beta B. Therefore, alpha beta not equal, then vector A equal minus beta divided by alpha B. Now it is like vector A equal lambda times B format. Therefore, here vector A parallel to vector B. If we get A vector equal lambda B, then we say vectors are parallel. No? But initially given they are non-parallel. Therefore, this is contradiction. Therefore, alpha not equal 0, beta not equal 0, the relation not true. The relation is not true. True. Therefore, alpha A plus beta B equal null only happen only for if and only if alpha equal 0 and beta equal 0. Here proper proof. You need to go with 4 different cases. Need to discuss 4 different cases. Okay, complete. Okay. Then question. OABC is a parallelogram. OABC is a parallelogram. OABC is a parallelogram. D is the midpoint of BC. ODAC intersect at M. Given that OA vector A, OC vector C. Find OD. Here OD vector, OC plus CD. OC vector, vector C, here half of A, OD vector. Then second one, OMMD, OMMD lambda is to 1. Find OM. Then OM equal OD vector divided by lambda plus 1 times lambda. Then OD vector, lambda over lambda plus 1, C plus half A. C plus half A. That is OM vector. Then third, AMMC, AMMC mu is to 1. Mu is to 1. Find AM vector. Then AM vector, AC vector divided by mu plus 1 times mu. Then AC vector minus A plus C. That means C minus A mu plus 1 times mu. Here AC vector. Hence find OM. Hence find OM. Then OM equal OA plus AM. AM. Vector A plus mu over mu plus 1 C minus A. Here OM. Using the results obtained 2 and 3, find the values of lambda and mu. Find the values of lambda and mu. Now here OM we got two different methods. Therefore you say lambda over lambda plus 1 C plus 1 over 2A equal A mu over mu plus 1 C minus A. C minus A. Now let lambda over lambda plus 1 equal K1 mu over mu plus 1 equal K2. ඒ විදිහට අලුත් දෙන්නෙක් දාගත්තත් හොඳයි. Then K1C K1 over 2A A K2C K2A. Now take similar terms together. K1 over 2 plus K2 minus 1A. K1 minus K2C vector 0. I think that is okay, no? Here we have two C vectors, K1 minus K2. Okay, now it is okay. Then separately equal coefficients. Here say alpha, beta, then alpha equal 0 and beta equals 0. Then K1 over 2 plus K2 minus 1 0. First relation. Here K1 minus K2 equals 0. Then K1 equal K2 second relation. Then substitute here. K1 over 2. K1 equal 1. K1 equal 2 divided by 3. K2 equal 2 divided by 3. K1, K2 both 2 divided by 3. Then K1 mean lambda over lambda plus 1. Lambda plus 1 equal 2/3. Then 3 lambda, 2 lambda plus 2, then lambda 2, mu 2. Find lambda and mu values. Both of them are 2. Simple question. Okay, complete. Okay. Now, question number 14, part B, coplanar forces question. Coplanar forces question. Yeah, ABC triangle, A 90 degree, A 90, AB 4A, A, B, C, here 4A, AC 3A, AB, BC, CA, AB, BC, CA, 4P, 6P, 4P, 5P, 6P. These are the forces now. Take this angle alpha, then find sine alpha 3A of 5, here 4A, then here this will be 5A. 3A of 5A, 3 divided by 5, cos alpha 4A divided by 5A, 4 divided by 5. Now, inclinations known, then trigonometric ratios are known. Calculate magnitude and direction of the resultant of the system of forces. And the position point where the line of action meet AB, produce if necessary. Okay, now resolve horizontally, then x equal 4p minus 5p cos alpha. Then 4p, 5p cos alpha, 4 or 5. Then here no x component, y component, 5p sin alpha minus 6p. Then 5p sin alpha 3 divided by 5 minus 6p. Then we get here 3p, downward 3p. Then resultant, we have only downward component 3p. We don't have any horizontal component. Then downward 3p. Now you mark resultant, produce AB. You better to mark this A. Here resultant, that is 3p. Then system moment about A anticlockwise equal resultant moment about A anticlockwise. To find line of action of the resultant, we need to take moment. Then here for A, you take this displacement B, then system moment 5p times perpendicular distance, here 4A alpha, 4A sin alpha. 4A sin alpha, sense minus. Here we can neglect these two forces. 5p into perpendicular distance, here 4A sin alpha. The resultant moment 3p into perpendicular distance b. Now simplify. Minus 5 into 4A sin alpha 3 over 5. 3b. b equal minus 4a. b equal minus 4a. That means, so I have taken from A this way, then other direction. Therefore, actually, okay, then the couple of momentum is added. The couple is added. Couple capital M is added. So that the line of action of the resultant of this system passes through A. Okay. Now the couple is added. Say capital M. Now the corresponding system now resultant passing through A. Then when we add a couple, only line of action of the resultant will be changed. Here magnitude won't change, therefore resultant won't change, magnitude won't change. Will be and direction won't change. Only line of action will be changed. Therefore, system moment about A anticlockwise equal resultant moment about A anticlockwise. Here, 3p times 4a plus couple m. Resultant here, it passes through a 0 moment. Then m equal 12pa minus. Here moment of the couple. So I have taken here anti-clockwise, therefore clockwise. Clockwise couple. According to my diagram, A, B, C sense. Initially I have taken A, B, C sense, but now the actual direction A, C, B sense. A, C, B sense. Okay, that is sketch number 14 part B. Okay. Then let's move to question number 15. Question number 15 contains joint dot and post notation question. Question number 15. So here two rods A, B, B, C, length 2L, weight W, azimuth hinge and B. ACR hinge to a vertical wall such that C above A. C above A. 15 part A. Here vertical wall. Here C above A. Weights W. W. Inclinations. Alpha to the horizontal. Here both of them alpha. Here and B, there's a hinge. So you mark horizontal vertical component here. Here mark X, Y. To cancel that one, mark downward Y and X. Then at this point there's hinge again. To cancel this X, you mark opposite direction X. Mark Y 1. Here to cancel this X, mark opposite direction X. Then upward say Y. These are the forces. Okay. All Y components are different, but X components are same because no any other horizontal forces. These are the forces now. Find reactions at ABC. Find reactions at ABC. Now, let's do this. Say, consider AB rod. Take moment about A. Here W into here is length 2L1 by L. W into L cos alpha. Y into 2L cos alpha. X into 2L sin alpha. X only minus. Then W cos alpha. 2Y sin cos alpha. 2X sin alpha. 0. Then BC about B moment. About B. About C. About C. Then W into L cos alpha. W into L cos alpha. XY 180. y into 2l cos alpha x into 2l sin alpha 0. Then w cos alpha 2y cos alpha minus 2x sin alpha, second equation. Then 1 plus 2, 2w cos alpha equal, here 5y cancel, minus 4x sin alpha 0. Then find x value. X equal w over 2 cot alpha. X value w over 2 cot alpha. Okay. Then 1 minus 2, 4y cos alpha 0. Therefore, y value 0. Y value 0. Therefore, reaction at B on AB. On AB. Here on AB, y component 0, x component w over 2 cot. And here w over 2 cot alpha. Here reaction on AB and B. Then reaction at C. You consider now BC rod. BC rod vertical forces y1 plus y equal w, then y1 equal w. Then reaction at C on BC. On BC, we have half on BC rod. Then we have x. W over 2 cot alpha. Here y means w. Then here reaction R1 equal w square, w over 2 cot alpha square root. Simplify to take w outside, 4 plus cot square alpha root divided by. Then take angle beta tan inverse w divided by w over 2 cot alpha. Then better to simplify this. Tan inverse 2 tan alpha. Here reaction at C. 12. Then consider AB rod. Vertical forces y2 equal w plus y. Then y2 again w. Then reaction at A on AB. So x component here is say w over 2 cot alpha and y component upward w. Then same magnitude, we get same magnitude. R1 same angle beta. Then we know R1, we know beta, same angle. Because we have same magnitude, vertical component w, horizontal component w over cot alpha. Only direction has changed. Okay. That is interpret question. Question number 15 part A. And further given that if BC light rod. Now BC light rod W is suspended. Find stresses BC and reaction at A. Now here this case, second case. Now it is like this. Here W, these are light rod. A, B, C light rod. Here where W. Angle alpha, then there will be stress. Let's mark tension. So if it is a light rod, surely there will be tension or thrust. Here these are weighted rod. And weighted rod contain horizontal component x and y at the edge, at the hinge. But here, light rod. Now you mark. Here there will be x weighted rod. Mark 5. These are the forces. Now, reaction at A. Find stress in BC and reaction at A. Simple. Consider. Take moment about A. W into L cos alpha. Here W into L cos alpha. Here L 2L, then 2L cos alpha. Then here T resolve. T equals 2 alpha passes through A, you can forget it. Then B sine 2 alpha perpendicular to R minus B sine 2 alpha into 2L. Then here cancel L 0. Then read W cos alpha 2 into T into sine 2 alpha 2 sine alpha cos alpha. Then cancel cos alpha terms. Then V equal 3W for cosec alpha. Here stress on BC. On BC. Thereafter you can resolve forces. Consider heavy. Resolve forces for only x equal T cos alpha. X equal T cos alpha. T means 3W for cosec alpha, then cot alpha. Then here x component. X component. Then resolve vertically. Y equal W plus W 2W minus T sine alpha. T sine alpha. Then 2W T sine alpha 3W 4. 5W 4. Now we know xy component. The reaction at A, you can reaction at A. You obtain here x component, there y component. Get resultant value and get direction as A. That is Exam-04 15 part A. 15 part. Complete. Okay. Then question number 15 part B. It is Gauss notation question. Gauss notation 1. So here the framework. 15 part B. Here the framework. Here 60-degree inclination. Here 60-degree inclination. First P, hinge A. And 45-degree inclinations. Here 45-degree inclination. Somewhat less than 60. Then here is 45 A, B, C, D, E. Here 400 Newton. First applied at C. Okay, then ADBE equal in length. Find stresses. Okay. Let's do this same. Now, here when you go to this vertex, you can find these two stresses. Thereafter, you move to this part, then you can find the other two stresses. Then you go to this one, then you can find these two. Then you go to here, then you can find remaining here. Then without finding P, you can go for that. But if you can find P directly, that's also okay. Here A. Then let's find P first. Take about A moment. 400 in here, this is A. Here 16 of A. Here tan 60. A over AB. AB equal A over root 3. Then tan 60 A over AB. Then AB equal A over tan 60 root 3. Then full distance A plus AB equal B times perpendicular distance. Sketch perpendicular. Here AB sin 60. AB sin 60. Then simplify 400 AB A over root 3. P AB means A over root 3. Sin 60 root 3 divided by 5. Now we can simplify them. Then 400 root 3 plus 1 over root 3 P over 2. Then P value 800 root 3 plus 1 over root 3. Now I can find this. Without finding P, we can obtain all the stresses. Now label regions, say A, say B, C, D, E, and F. Now start from vertex C and move anti-clockwise sense. Then here AB downward 400. BC to the horizontal 45 inclination. CA horizontal. Then here this will be C. Same time mark forces. BC, here is A. CA, here is A. Okay, then here 45 inclination. Same time you better to update the table. Then rod, stress, tension, or thrust, and then magnitude in newtons. So BC rod and CD rod now we have contacted. Then AB 400, then BC. Here BC we have thrust, CD we have tension. Then BC AC region, CD BC region. Then AC length, AC means AB 400. Then BC, here 400 root 2. Then AB equal 400, BC equal 400, AC. BC equal 400 root. Okay, then thereafter you come to this vertex again. BD horizontal, DC vertical. Here D. Same time mark forces BD. Here is say DC upward. Then both table ED rod and BD rod. ED rod tension, here trust. Okay. Then find forces. Then ED represented by BD. BD represented by CD. Then BD same 400 Newton. Then CD again 400 Newton. So these are very easy. Then you go to here this vertex DE to the horizontal 60. DE to the horizontal 60. More than 45 degrees. Then EA horizontal. Here DE this same, EA horizontal, then simply E. Then DE, EA this side. Now go to the table AB and BD. AB thrust, BD tension. Then AB is separated by AE, no? AE. BE. Yeah, BE is separated by DE. D. Then you find this value. DE sin 60. DE sin 60 equal AB 400. DE root 3 over 2. 400, then DE equal 800 over root 3. Then DE 800 over root 3. 800 over root 3. Then AE full length. AC being 400. DE cos 60. The angle 60 now, then DE cos 60. Then 400 DE 800 over root 3 half. Then 400 1 over root 3. 1 plus 1 over root 3. Here AE 1 plus 1 over root 3. Is. Okay. Then so we have only one rod. Then move here FT vertical. Before that BF just B. Here B. Here FT vertical. Here it is. Now FT downward. BF to the horizontal 60. Yeah. Then AE tension. AE that represented by EF. Okay. Then BF. Yeah, BF. That is P now. Then BF, angle 60, BF sin 60. Yeah, BF Sine 60 full length EF plus DE sine 60. DE sine 60. Then BF mean 800 root 3 plus 1 over root 3 over 2 EF DE root 3 over 2. Okay. DE 800 over root 3. 800 over root 3 root 3 over 2. Now we can simplify this one. We can simplify this. Here 2 cancel, root 3 cancel, 400. Here 400. Then here 400, 400 cancel, 400 root 3 repeat. Then here 400 root 3. 400 root 3. Yeah, 800 divided by root 3. Here 400 root 3. Those are discussions. Okay, complete that one. Okay, now we have only one another question. Question number 16. Question number 16, center of gravity question. So initially there's a proof part. I'm not doing that for now. Hemisphere radius a cone is cut. Okay, here hemisphere A. It, then find center of gravity. Initial proof දෙකක් තියෙනවා. ඒ දෙක දැන් මම කරන්නේ. Here by symmetry, here x axis, y axis. By symmetry, center of gravity lies on the x axis. Therefore, y bar 0. Y bar 0. Then mass per unit volume rho. Then object mass center of gravity. Take this table. Hemisphere, cone, then the remaining body. 2/3 pi a cube rho, 1/3 pi a square, height again a rho, then subtract 1/3 pi a cube rho, 1/3 pi a cube rho. Then here center of gravity 3 a over 8. Here solid cone h over 4, that means a divided by 4 x bar. Here height a, height a. Then by taking moment about y axis, then 1/3 pi a cube rho x bar, 2/3 pi a cube rho 3a over 8, 1/3 pi a cube rho a divided by 4. Here the moment, force into perpendicular distance. Here mass into center of gravity, mass into center of gravity, mass into center of gravity. Here subtract these two, the remaining body we can get. Now simplify 1/3 pi a cube rho, 1/3 pi a cube rho, 1/3 pi a cube rho. Then x bar 3a over 4 minus a divided by 4, we get a divided by 2. Here center of gravity a divided by 2, simple. Now thereafter, the body placed on inclined plane, let take this angle theta. Here it placed like this. Now here the system now. Reaction passing through center of gravity. W here there will be friction. Otherwise we can't put that way. Okay. Now we need to show that theta equal 30. Then here angle theta. Here theta 90 minus theta, 90 minus theta. Here theta. Here x bar. Then sin theta x bar divided by a. X bar divided by x. X bar a divided by 2. Then here half. Theta equal 30 degree. Theta equal 30 degree. W is the weight of the hemisphere obtained in terms of W values of frictional force and normal reaction. Then here resolve this one. Resolve perpendicular to the surface. Here theta R W cos theta. R equal W cos theta. Then theta value 30 now. Cos 30 root 3 divided by 2. Then F W sin theta. W sin theta. WO2. Okay. Those are the frictional force and the normal reaction. Find also the smallest possible value of coefficient of friction. Coefficient of friction, we know mu greater than or equal F divided by R, no? Then mu equal F for R. Take this mu equal F divided by, at the limiting portion you can take this. F equal W over 2, R mean root 3, W over 2, 1 over root 3. Here, coefficient of friction 1 over root 3. 1 over root 3. Simple question. ඒක හරියට පොඩි වෙලාවකින් හදන්න පුළුවන්. proof දෙකට විතරයි වෙලාව යන්නේ. හරි. එතනින් ඒ part එක එක් paper එක දැනට ඉවරයි. මේක ඉතිරි ප්‍රශ්න ටික ආයෙ මම වෙනම discussion එකක් දෙන්නම්. දැනට අර කරලා තියෙන ප්‍රශ්නත් එක්ක තමයි මම වැඩියෙන් complete කරේ. Okay. අපි එන අතන ඉවර කරමුනේ.